Assalamualaikum warahmatullahi wabarakatuh and a good day everybody. So now we are continuing our lesson in this chapter number 5, equilibrium energy body. So basically we already understand what will be the condition of the equilibrium of a rigid body. So now we already understand how we want to draw the free body diagram. So now we move to another topic, the equation of equilibrium. So we are focused on the 2D. For a frame of rigid body in 2D, the resultant force or total force in X component should be equal to 0, and also the Y component, the total resultant force in Y component is 0, and the total moment about point O is equal to 0. So total forces equal to 0, so the Y force Y in Y direction equal to 0, and total moment about any point O, for example, equal to 0. Okay, so the total resultant force X and force Y represent the sum of X and Y component of the forces. Resultant moment represent the sum of couple moment, and the moment of force component should be equal to 0. Okay, we can see this example. So determine the horizontal and vertical component of reaction for beam loaded and neglect the width of the beam calculation. So here we have two support reaction A and B here. So you need to open back your textbook, our textbook, static RC tubular. So now as I say in table 5.1, so we need to check what will this type of connection, what will the reaction force, and how many unknowns. Okay, open your back textbook now. Okay, so now we have the external force here, 600 Newton, given by 45-degree angle, and also we have also the external force D here, 100 Newton, and also 200 Newton on top of the point B here. So we can see here this actually have a plane of the eliminated from this point to this connection A and B is a little bit 0.2 meter gap. Okay, so I want to solve this problem. Now we want to draw the free body diagram. So here, after you are referring the type of connection in table 5.1, we have noticed that they have a one unknown at point A, the separation type of connection at E, and there will be two unknown separation type for the B, so By and Bx here. So 600 Newton with angle we resolve to the X component, Y component. We have the for Y 600 sin 45, for X is 600 cos 45, and also we have the D 100 Newton. So 600 Newton represented by X and Y component, 200 Newton force add on at beam B. Okay, so in equation of equilibrium, first one we taken out the total resultant force in X direction equal to 0, whereby what will be the total resultant force in X component. This will be in X component 600 cos 45, this one direction to the positive X. Okay, so Px the direction to the negative X. So only two force in X component, Ay 600 sin 45, D here at B here 200, and 100 this one, and also By is all in the Y component, it's not in the X component. Okay, only 600 cos 45 minus Bx is 0, so Bx equal to 424 Newton. So take a moment about point B. So any forces at B will be cancelled out. So By, Bx 200 we cancel out. So only left how many forces? Ay 100 Newton, 600 45, because this one is not same line with the point B. So at these forces acting on this particular point is not same line of point B. So we need to consider these two forces, 600 cos 45 and also 600 sin 45. So here the total resultant moment about point B equal to 0. So 100 Newton. So where is 100 Newton? So 100 Newton here. So going down. So rotate about point B. This one is a clockwise. This one is a counterclockwise. So how many what we perpendicular distance from 100 Newton is a 2 meter. And then next one is the 600 sin 45 this one. So this one going down and then rotate about point B. This is also the counterclockwise. Well, we the perpendicular distance from the 600 sin 45 to the point B. So 3 meter plus 2 meters, 5 meters. So you can see here 5 meters. Next one is a 600 cos 45, go straight here and then going down in order to rotate about point B. This one's a clockwise. So 600 cos 55 and also multiply by 0.21. This one 0.2 is perpendicular distance with the 600 cos 55. You can see a negative because we are considering the counterclockwise positive, so the clockwise is will be here negative. Okay, the next one is the AY here and then go up and then rotate to point B. This one also the clockwise direction. So AY perpendicular distance from AY to B is a 2 plus 3 plus 2 is a 7. So this one is negative AY multiplied by 7, negative because this one is a clockwise direction equal to 0. So we're solving this equation, only one unknown here, so steadily we can determine the AY. So AY is equal to 319 Newton. So we have done for the first equation of equilibrium. So total resultant force in X component equal to 0. Second one is a total resultant moment equal to 0. So now is the third equation of equilibrium, which be a total resultant force in Y component equal to 0. So what we learn with Y component. So AY is a Y component, going up is positive, 600 since 45 is going down, this one negative, so 100 Newton going down, this one is negative, 200 Newton going down, this one is negative, BY is going up, so this one is a positive. For VX and 600 cos 45 is not considered because this one is in X direction. So we have here 319 Newton. 319 Newton is AY, so AY already developed, so AY 1, 2, 3, 4, 5. So AY here 606 in 45 is a negative, 100 Newton is negative, 200 Newton is negative plus BY because BY is going up is positive, so you get to 0. So only one unknown here, so we can get the BY. So BY is equal to 405 Newton. Okay, so finally in this one is the last topic in our chapter in equilibrium of rigid body to force member. Okay, so force member, what we mean by two force member? When forces are applied at only 2 points on a member, the member is called a two force member. Only force method must be determined. So here, for example, we have a little bit cable here. So we have the two forces, force A in this direction, force B in this direction. So let's see the FA. You want to make we want to equal to some point force FA. So the now we want to make the change the force A and force B to same magnitude. So force A and force B, so we are changed to in this line. For example, in this line of action, force A is equal to F, force B equal to F. So meaning that there will be a two force member. So right now it's because the same line, this one the same line, so only the force is opposite direction. Okay, so I think this was our topic in this chapter number 5, equilibrium of rigid body. So I will give you a tutorial as an exercises, many exercises that you need to do, and then we can discuss on the next class. Okay, see you in a new chapter number 6, structure analysis. I hope you can stay on the whole for this course. Hopefully we will meet the next chapter in next class, in next session. Okay, see you, bye bye.